All right, continuing to work with reduction formulas. I have another example that I want us to work on that will continue giving us some familiarity with making reduction formulas. And what I want you to do is pause the video and try to find the reduction formula for this down here. And I've given you a hint. This is going to be your first step here in yellow. So pause the video, try to construct the reduction formula. All right. Assuming that you've given it a go. Again, what we've seen in the previous videos is once we have our reduction formula, using it makes our calculations and our lives a whole lot easier. So as long as we can get that reduction formula, applying it to an example makes our lives easier. So what we're going to do is just focus on making the reduction formula here. And I've already told you our first step is going to be this in yellow. So let me just write that out. We're going to have capital F. This is our notation. Capital F sub n of x is going to be equal to this, the indefinite integral of e to the x times a tangent of x and all of that to the n minus 2 power. And then we're multiplying this by tangent of x and all of that squared. Okay, and then dx. So this is what we have for our indefinite integral. And again, this is the same exact thing that we have up here. We just rewrote it so that we can now state a trigonometric identity on tangent of x squared. And we're going to recall that tangent of x, all of that squared, is equal to secant of x squared, and then we have minus 1. This is a trigonometric identity, and we're going to apply this because, again, where are we headed? We want to eventually use integration by parts to start constructing our reduction formula, and doing this is going to help us out in that regard. So let's write that out. This is going to be equal to indefinite integral e to the x. We're just keeping everything here, and then we're going to throw in this trigonometric identity. So we have secant of x, and then this is squared, and then we have minus 1, and still dx. And now what we can do is distribute this, and we will get the following. We will get this now. We have e to the x times tangent of x. Again, this is the indefinite integral. And then we have this here, distributing. So this is going to be times secant of x, and then all that squared. And then we have minus all of this here, minus e to the x times tangent of x to the n minus 2 power. All right, and then all of this we're still integrating with respect to x. And what we can do now is apply one of our integral properties. We can split this into two separate integrals, and you're going to see that we're going to get something cool out of this that will allow us to start making some progress on our reduction formula. So let's split this into two integrals. And we have this. We have one definite integral, which is going to be e to the x times tangent of x to the n minus 2 power, and then times secant of x squared. And then we have minus, actually, let's throw in, we want two separate integrals. So this is integrating with respect to x. So this is one of our integrals. And then we have minus another indefinite integral of this here. So e to the x times tangent of x to the n minus 2 power, integrating with respect to x. These are our two indefinite integrals. And remember, when we're constructing these reduction formulas, we're trying to state this original integral in terms of a simpler integral. And you can see we've already accomplished some of that. Right here. Let me get this here. Right here. This is what under our notation? Well, this is going to be capital F sub n minus 2 of x. That is what this is right here. Capital F sub n minus 2 of x. So we're already making some progress. And again, when we've constructed reduction formulas in the last few videos, we've had to apply integration by parts. And now, since we've used this trigonometric identity up here, this integral right here, let me get that in a different color, right here, we can apply integration by parts on now. And maybe at this point you want to pause the video and try out integration by parts on this. All right, let's do some integration by parts. So we need a u and a v prime. So u, let's look at this. What do we want u to be? Well, I'm actually going to say that we want that to be e to the x. And the whole reason why is this remaining part right here. This remaining part right here, we can take its antiderivative. We know what that is. So we're left with u is equal to e to the x, and then differentiating. We love differentiating e to the x because it's just e to the x. And then we said that v prime, we actually wanted to be all of this. We wanted that to be a tangent of x to the n minus 2 power times secant of x squared. So that is what v prime is. And then anti-differentiating, we can do this because why? The derivative of tangent is secant squared. So just undoing some things here, you're going to unravel this. You're going to have 1 over n minus 1 times tangent of x to the n minus 1 power. And differentiating this, you can see that this is exactly what we have over here. Applying some chain rule, we're going to apply this power rule here. So this is going to be bringing down n minus 1. That will cancel to 1, and then we decrement this exponent here. So now we'll get n minus 2. And then by the chain rule, the derivative of tangent is secant squared. So hopefully that you can see the chain rule working here. This is our integration by parts setup, and now we can just write things out. So let's apply this and see what we have. Let's see here. This is just going to be for this integral. We'll bring down our other result from this other integral when we get through some of this integral here. So u times v, that's going to be e to the x. So we're just dealing with this integral right there. So e to the x, and then we have times 1 over n minus 1 times tangent of x to the n minus 1 power. All right, so that's u times v, and then we have minus this indefinite integral of v du. That's going to be 1 over n minus 1 times tangent of x to the n minus 1 power, and then we have u prime, which is going to be e to the x, and then dx. This is just integration by parts laid out for us, and now let's see what kind of things that we can pull out of it. Again, we're trying to get this integral maybe to look like something in our notation. We want capital F sub something of x coming out of this. So let's see what we have. Looks like in this integral, we can factor out 1 over n minus 1. That's just a constant, and that might help us out. So let's write this out. We have e to the x times, we'll just put this under e to the x. So e to the x over n minus 1 times tangent of x to the n minus 1 power. And then we said we're going to take out this 1 over n minus 1. So we have minus 1 over n minus 1 times the indefinite integral of, and now we have tangent of x to the n minus 1 power times e to the x. Let's make that neater. Times e to the x dx. And what is this right here? What is this guy right here? What is this guy right here? Let's scroll back up. So under our notation here, that is going to be capital F sub n minus 1 of x. And that's exactly what we were after. So we got another piece going in here. We have capital F sub n minus 1 of x right here. And now we have all of our pieces to express our reduction formula. So let's just put everything together and see what we get. So we said originally we wanted to find capital F sub n of x. And we found this to be, combining all of our answers here, this is going to be e to the x. And then maybe we can factor out. Yeah, let's factor out a 1 over n minus 1. Let's take that out. So we have 1 over n minus 1 times everything in here. So this is going to be e to the x times tangent of x to the n minus 1 power, n minus 1 power. And then we have minus what we have here in green. So capital F sub n minus 1 of x. And again, that's because we factored out 1 over n minus 1. So this is all that we have left in here. And then that is everything up here in pink. And then we cannot forget. We also had this up here, minus capital F sub n minus 2 of x. That is our last piece. So let's put that in. So we have minus capital F sub n minus 2 of x. And this right here, ladies and gentlemen, is our reduction formula. We have constructed our reduction formula. And again, you could apply this But this is the hardest part. Once we have this, we could apply it and our calculations are far simpler. And really, the main thing that we had to note is this first step here. Once we had this first step down, and I gave it to you, that applying a trigonometric identity allowed us to construct two indefinite integrals, and we were able to make some progress and eventually apply integration by parts and construct our reduction formula. And in the next video, we'll get some more practice with reduction formulas.